Hi, I welcome all of you in first part of the lecture that is based upon regression analysis. Regression analysis is a statistical technique that is used for the prediction of one variable based upon another. The variable that we predict is known as dependent variable, and the variable that is used for the prediction is known as independent variable. The dependent variable is mostly represented by y, whereas the independent variable is represented by x. We have one dependent variable at a time, and there may be one or more than one independent variable in our regression model. These independent variables are represented by x1, x2, x3 likewise. And application of the regression analysis is mostly in the business, in the engineering, medical, statistics, a lot of the fields. Let's discuss few example. We want to forecast the sales. So sale is my dependent variable and we want to forecast it by based upon advertising investment. So advertising investment is my independent variable. We call it X and we call sale as Y. There is one dependent variable and one independent variable. And this in this example, predict population growth rate for a country as a function of birth rate and death rate. So birth rate is my first independent variable, death rate is my second dependent variable, and the population growth, this is my dependent variable, and that is only one. So this was the application. If you talk about the application of regression analysis in the field of engineering, for example, you can see that surface roughness can be predicted by using three variables. So we can say that these variables may be spindle speed, depth of cut, feed rate, and so on. So I take three independent variables in this case. When we have one dependent and one independent, we call it simple linear regression. Simple linear. And when we have one dependent and more than one, so 2, 3 and so on, we call it multiple linear regression analysis. The regression analysis is used for identifying the cause and effect relationship. Earlier to this lecture, I have uploaded the recordings for the correlation analysis, and the correlation analysis doesn't tell us about these cause and effect relationship. This relationship can be modeled by using the regression analysis. So we want to check that whether online promotions, so these online promotion can affect sales or not. So online promotion become my independent variable, that is X, and sale become my dependent variable Y. The application of regression analysis is also in the field of optimization. We want to find the optimal mold temperature, that is my independent variable, in the injection molding process that minimize the wrappage in the products. So wrappage become my dependent variable Y. So these were the applications of regression analysis. So this is the mathematical model for the simple linear regression, where y is my dependent, x is my independent variable. Sometimes we call y as yi. This b naught is the y-intercept and it is shown there. It is a point where our line intersect the y-axis and is known as y-intercept. Beta I is the slope of this regression line. This beta I can be positive, it can be negative. If the line is going upward, the sign will be positive here. If the line is coming in, suppose the line is going downward, in that case our beta I will become a negative because the slope is negative. So the slope is change in y with respect to change in x. Here the y increases as, here you can say as the x is increasing, our y is also increasing. So slope is positive. Beta I has a positive sign. In this case, where the beta I is decreasing, in that case our slope is negative because our y-axis value is going downward as our x-axis is increasing. So this is the case for the beta I. We call it beta naught and beta I as the regression coefficients. After collecting the data, we make a scatter plot. In the scatter plot, we have only these dots. that represents some pattern in the data. The pattern can be increasing, decreasing, or there will be no pattern. The second step after plotting all these points is to make a line that fits this data. So there are two kinds of line. The first one is true regression line. The true regression line here represented by this blue color line, and this blue color line is the true regression line based upon the mean values of the data. After drawing this line, we make one another line that is known as fitted line. This fitted line is based upon the regression analysis, and this fitted line is used by one of the most commonly used regression analysis method, that is known as least scarce method. Now will fit the line among these data points in such a way that there will be the distance between point to the line will become minimum. For example, this is the point and this dotted line. This distance should be minimum, and this only possible if we use the method of least square.